Hey, and we are live again. Welcome to our YouTube. Welcome back to our YouTube channel. And I'm Anton Arhipov, and I'm welcoming you to this new session in our series of the webinars that we are running weekly right now. And last time we had a session about Apache Pulsar with Kotlin. It was a pretty interesting one, a very interesting data streaming library. This time we are going to have a session about a jqwik library for testing, for property-based testing. And next week, we are waiting for Lucas Eder to join our show for demonstrating Juke with Kotlin. So towards today's session, during the stream, you can ask questions in your Twitch login chat or in YouTube comments. And feel free to ask questions. We are going to address them as we go. And without further ado, I would like to welcome Johannes. He's the maintainer of this awesome library. And hello.
Hello, Anton.
Hi there. So today, it's another testing library that we are going to talk about. And we have JUnit for testing. We have test containers for integration testing. We have some mutation testing libraries, and now property-based testing. To be honest, this library looks to me like a hidden gem for Kotlin and for JVM ecosystem as a whole, because even though I knew about the concept previously, I didn't know anything about the library before you reached out to me. So I think this is something that a lot of people will discover today, and they will like it. I think they will love it. So the floor is yours, and I'm going to stay with the stream with you, so that I make the impression for the attendees that you are explaining the things to me.
Okay. Yeah. Thank you very much, Anton, for this nice introduction. Yes, indeed, it might be a hidden gem for the JVM, and I'm very happy to be here today and to be able to present it to you. It's all about property-based testing, and I hope that the library as such will only be, well, a feature, a sidekick, so to speak, and I think the concepts are more important than the library itself. So if you want to contact me, go to Twitter, follow me, and get into contact. So that's about it. So let's dive into the topic. I think that most of you, since you are here, that you're already doing some kind of automated testing, like with CodeTest or with JUnit or with any of those libraries. And those libraries, what they doing most of the time, or even all of the time, depending on how you use them, is that you are using examples to test your code. Yeah, and the special thing about an example is that you are dealing with a specific set of inputs, and that you then that you expect a specific result. So let's look at an example. This example is a rather mundane one for project management. As you can see in the code, hopefully you create a project with a name, and you add members to it, and the members are users, and they have email addresses. Yeah, and then you check that the members you add that are really members of the project. So far, so simple. The problem that many of those example-based tests have is that they promise things that they cannot keep. So if we are looking at the title of this test, for example, yeah, it says you can add many team members to a project. Yeah? But if you look at the test code, actually what it's really testing or really checking is that you can add 3 members to a single project with one specific project name, and the 3 members that you add, they have 3 predefined email addresses. So the problem that you have with this promise, yeah, so it's claiming to do some very generic thing, yeah, adding many team members, but actually you cannot be really sure that the example test that you have that they are sufficiently representative, though, that they cover the full realm of this feature. There could be more to it. Yeah, there could be what's happening if you're adding 1,000 members, for example, or does it cover all the edge cases, like is any project name possible? Do project names have any prerequisites? So you see there's edge cases, there's problematic cases that there might be, or this domain constraint that are usually everywhere. They are not really covered by the test case, and it does not even communicate those domain constraints. So just from the test, you can't really see what are the for example, what's the maximum length of a project name, or what kind of email addresses or addresses are allowed there. So the question I have been asking myself for this 20 or so years that I am doing example-based testing is how can we make a test more powerful so that it keeps its promises? And one answer that, or the usual answer that we give is we just add more tests. So to explore the full space of possible inputs, we just add more and more tests. But actually, we cannot explore the full space. So we have to stop at some time and then hope that's enough. And also adding more tests means more work. Yeah, you have to think about all the edge cases. You have to think about what differentiation in the input data could potentially make a difference to the output and all that. And you have to do that by hand, always pairing a specific input with a specific output. We can have a different look at it. So, and this look are those properties. That's where the name property-based testing comes from. So, and a property is not a specific input to output, but it's a class of input. So it's trying to make a generic statement, a generic expression about what your code does in general, not just for a single example. So you have a class of inputs with preconditions usually, and then you get some generic qualities. And what I want to try here is now in a demo to migrate this example that I've shown you into a property and see if we can learn something and what the result is going to be. So let's change to IntelliJ. Here in IntelliJ, I'm already using jqwik, which if you want, you can also use as some example-based testing framework. Just use the word example, which is more or less what JUnit gives you with a test annotation. So let's start it. And not surprisingly, at least not surprisingly for me, it succeeds. So we could rely on the project class working as it should, but we want to go a bit further. So the first step into migrating that into a property is just changing the annotation. So just doing property and then rerunning the test with Ctrl+R. Okay, what can we see here? We see here that one thing that has changed, we get more reporting. Yeah. So what we see here is we have like 1,000 tries and 1,000 checks that are being executed. But to be frank, just running the same test with no variation 1,000 times doesn't really, most of the time it doesn't provide additional value. So we have to introduce some variation to make that more interesting. And the variation, what the jqwik framework uses for injecting some variation is to have parameters, and parameters annotating with a for all annotation. So to make that a bit like a language for all. Here, let's start with a simple example. For all project names of type string, this property, which is then just like a test, but a test that now will be run 1,000 times with a varied project name. Let's see what it's doing now. And it's still running. It's still running quite fast, and we still can't see a thing because we are doing something. The variable exists, but we are not using it. So just to make sure that anything is happening here at all is to look at what the project name is really that's being handed in by the framework. So, and what we can see here now is that the range of generated strings is quite large. Yeah? So it's pseudo-randomized, but not only. What we can also see is that here we get empty strings, we get strings with just a space, we get strings of different lengths. We hardly get any Latin character here. Let's see, and this is because in the Unicode realm, Latin characters are so rare that they are hardly generated when you just go with random characters. We could change that. We could say use alpha jars here. Okay, let's see. Here we get some variation. Okay, and now we see we get only standard Latin characters being generated. Okay, let's go with that and replace the hard-coded project name with this variable and see if we're already learning something. Yeah. And now it's really used. And suddenly we see that not all project names are acceptable to the code, at least as it is. That might be a problem with the specification, or it might adhere to the specification and just the test does not really communicate that. And if you're looking at the error message, the project name must not be blank here. By the way, what I'm using here is the Kotlin power asserts. I just discovered this library a few days ago and added it to this example. It's just rearranging the code, like the require statement. Let's look at how the actual code looks. So what we see here in the constructor of the project, we require that the name is not blank. Though, and this is what the code actually tells us. The error message actually tells us. So we can we have to, in order to make this property work and to document or to stick to the specification, we must generate project names that are not blank. In this case, we are lucky because there is jqwik comes with a property with an annotation that does just that. Yeah, it just cares that there are no blank means it's not an empty string and it's not having only white space characters. Yeah? So this is what not blank is doing, and this still works. This hopefully works now. That's my hope. And yes, it does. So it's now trying 1,000 different project names, and this alpha chars was just for presentation that alpha chars can be generated. But in our world's software, we should be able to deal with any kind of names, yeah, in all different languages, such that I will try it with just not blank as specification. And right, okay. So I think we have already added a little bit of value to this original example test, because now we have documented that these project names, they are not allowed to be blank. Okay, let's be a bit more ambitious. Let's try to get rid of these hard-coded users as well. And what we see here is that we are creating the users out of emails. So one idea is, or the one I'd like to follow, is to start with a list of email addresses and build the users from there. Now, this is basically a similar thing. We want emails, and we want the emails to be a list of string. Okay, so far, so good. Just running that just tells us that the framework is able to generate list of strings. Yeah, they are not used there anywhere, but we know, okay, jqwik is not just able to deal with primitive types out of the box, but also with list of primitive types out of the box. So next step would be to create users out of that. So let's see, we can map those users into map the emails into users. It's just like this one. Let's see if that works. One step at a time. And hey, we get an error. So, and the error we get is the email should not contain exactly one @ sign. So it's doing a primitive way of testing if this is a valid email. Yeah, this is not going through the full specification, but at least it's a bit of semantic checking. What we can also see here is if we are looking at more of the generated data. So what jqwik is providing is the original set of data that was generated pseudo-randomly, and this was a rather strange project name. I hope this is not an insult in Chinese or any other Asian language. And it's generating emails from some kind, and this failed, yeah, because none of these emails actually has an @ sign in it. So even the first one will fail. But we also see something else. What jqwik is doing, as soon as it has detected a failure, it has, so to speak, falsified the code that we already have seen there. It's trying to make these randomized examples smaller. It's called shrinking them. And what it did here, it came up with a single letter project name, which still generated the same problem, and with a list of emails, just one email in this list with an empty email. This is, I'd say, it's the smallest set of data that can reproduce this error. So it has shrunk the original sample really to a very small example that's much more expressive and much easier to debug, yeah, if we have to detect this error. So what we have to do is we have to generate not list of any strings, but we have to generate list of emails. And again, I've cheated a bit. No, I've not really cheated, but I've chosen the example to play to the strength of jqwik, because jqwik comes with a lot of built-in generators, and email is one of them. So what we can do now is here we can just say generate emails, and let's check if that works. What you notice now is that generating 1,000 emails is not as quick as one might hope. Yeah, that's why the test is running a bit. It's almost, it's running 11 seconds. That's quite a bit. Usually data generation is not the bottleneck of the framework, but if you really want to explore the breadth of what emails can be according to the W3 standard, that's quite a lot. So that's why email generation is taking a lot of time. I will show you to speed that up a bit. One other feature of jqwik, that is you can manipulate the number of tries, yeah, the number of experiments it's running.
There was a good question in the chat, whether or not it's possible to create your custom annotations.
Yes, it is. It is. I will not show that today, but that's possible. So let's go for 100 and speed that up a bit. The thing is, if 100 or 1,000, whatever your default is, it's never if it's never being, or most of the time it's not being enough to cover the full range. So you have to find a sweet spot for you or for your special context. Yeah, what a good default is in that. So okay, so we can now generate emails that correspond to the email specification. Now that we have the users, we want to use that users to actually do the testing for us. And I could go with a usual for loop, or just let's do that one, and just say add each user to the project, and then check each user that it's a member. Well, I take that up, is a member, it. Okay. That means I can hopefully get rid of that code. And let's see if our code will adheres to this property that we have. So now the test is taking a bit longer, and that is usually a sign that it has found a failing test case and is now shrinking, what I already explained to you. And the shrinking, which only happens when you have failures, can take quite a lot of time, because shrinking in the general case is searching through a vast amount of possible inputs, and it's usually not doing a full search, but it's doing a heuristic search and that. But it still can take quite some time. But nevertheless, it found another problem. The maximum number of 10 members already reached. So it seems like where's the actional failure? Require capacity. If we look at the code, there is some hard-coded limit for the number of members, and this is reached. So what we have to do is actually, if we do not want to change anything in the configuration of project, we have to limit the number of users to a maximum of 10. And this is within what jqwik can do out of the box. Let's see. Okay, let's check. So hope dies last, but in the end it works. But there we see, because I know there is another bug hidden, or there is another problem hidden, that sometimes the 100 is not enough. I have to either retry again or raise the number of tries. Let's see if that will already reveal our problem. And it seems okay. So what we have here is member with email, short email, already exists. So what that tells us, if we dive deeper into the code, is that different members have to have different email addresses, which is the usual constraint. So this is one that we also have to make sure that we can fulfill when creating our users. And then, since this is a common thing, I could either go for a set of email addresses, which would automatically filter out duplicates, or I can use, if I still need a list for some reason, I can use a special feature here to filter out duplicates. Rerunning. Okay, it works, but I know there is still some hidden problem in this code. And I would have expected it to show up in the first run, because it usually does. So depending on the edge cases you have and the problems you have, 1,000 is often enough to show the most common problems. And the reason for that is that the data that is being generated is not only pseudo randomly generated in equally distributed over the whole space of possible email addresses, for example, or the possible number of email addresses in the list, but it's preferring edge cases. So edge cases, for example, for strings, it's preferring an edge case, an empty string, or just one with one thing. Or for numbers, it's preferring the highest and the lowest possible numbers and stuff like that. And that's why the usual suspects show up usually with quite a few tries. So you don't have to really do it a million times to hit on an edge case that is only by chance would be hit only in every millionth try. So the thing that we see here is we see the same problem that we saw before. Yeah, we see that it claims that the same email address has been there before, although we said make it unique. Let's see what the actual problem is. Let's dive into the code. And this seems to email known. This looks all right. Yeah, we check for duplicate emails. So the problem may not be here, but might be somewhere else. For example, in the user. And actually, I know it because I've put it there, the bug, and I consider it a bug. What the user is doing, it's trying to somehow standardize emails by making it lowercase. This lowercase thing for emails is actually correct for the address part, but it's not correct for the local part. So if you look at the specification, what emails can do, they can differ by just upper and lowercase in the local part, so the part before the @ sign. And that means, although some email providers, I think like Gmail, they do not differentiate between uppercase and lowercase letters for the same unique email address. But there might be others that do, and that do according to the specification. So that means we must be able in our code here to deal with email addresses that only differentiate by upper and lower cases. So let's fix that, and then hopefully make the test pass now with 1,000 tries. And it does. Okay, fine. One more problem there, however. When I look at the code here, what I'm doing, I'm dealing with generating primitive things like strings or lists, which are still not really primitive in the JVM sense of the word, but it's still primitive in the sense of it's not what we usually have in our programs. What we have in our programs is things like we have a project class, we have a user class, we have certain kinds of tuples, for example. And usually what I want to use in my tests is those types as well. So I want to formulate my properties in the language of the domain. And so we need this capability in a testing library as well. Let's see how we can do that. I'd like to change the name because actually this name is wrong, because this property only tells us that you can add up to 10 team members. Yeah? There is a way to manipulate the project class to have more, but the thing that we know now, it's up to 10 team members. And what I want to have here is, I do not want to use emails, but I want to really get the users right in there. So we have like user. That's what we want. And then I know if I have a list of users, I no longer need mapping emails on that. Okay, so here we go. Let's try that. I think it should surprise you if this worked, because how should jqwik know that how to generate a user from nothing? Yeah, because it might be a complex object, it might have a lot of domain constraints what a user can do, and it can't know so. So what we need is, for those cases, we need some way to declare or to program our domain types. And there are many ways to do that. But one of the ways is members, is to say, here, take my generator from a method. And this annotation provide actually suggests that provide generated domain objects, and the type behind that. So we have like a monadic type, and it's called an arbitrary. This is it inherited from jqwik, which is the oldest library for property-based testing. You can think of an arbitrary as like a factory of random generators, or a factory of generators. So what we want is, we want a list of user. A list of user. Should be, sorry. This is the fun part. And you see, I'm programming more in Java, so that's why I started with the type. But actually, this is better. Members. Okay. So this is the function in which to encode our generator. And what you can see here, in this case, it's this name that refers to this function name. There are other ways to inject generators, handmade generators, but this is the simplest one, so to speak. So I can return, or no, let's be more Kotlin-ish, so to speak. Let's do that as a function. So what we have here, the primitive thing we want to start with are the emails. And the emails are located in this web object. It's an email, and I want to map an email to a user, just like we did in the hand-coded property before. And we want a list, and we want unique elements. So that's about it. And now what we have done is we have defined a generator for a list of users, and a list of members, sorry, and members must have unique email addresses. So that's why this works. And now you can see this generator is being used here within this test. Are there any open questions, Anton?
Yes, there are, and I think one of the most interesting questions to me, whether or not it's possible to make those tests deterministic. So imagine you have created a test, you have tuned it, you have kind of discovered some failing combinations of the inputs. Yeah. You commit it, you run it in a CI environment, and it fails because the generators work not exactly the same way, or are they working the same way?
So there are two answers to that. The first answer is it usually does exactly what you'd like it to do, which means when you're working in your IDE, what it will do is it will, if as soon as a property fails, the next time you run it, it will reproduce just the single example that failed, and it usually will generate the shrunk example that failed. Yeah. And as for continuous integration, it's using the same mechanisms. What you can see here, it's generating a seed per property. So so you either, if you want to reproduce the exact sample that failed in your continuous integration, you just use this seed. You can have it here to reproduce it, like seed, and then put in the seed that you get from the reporting in your CI, like that. Yeah, that's how you would do it. Or if you configure your CI that it won't delete all the files in your working space, in your working directory, it will do that automatically for you, and it will do that until the test or until the property succeeds again. and then it would go over and uses a new random seed. So you get, most of the time, you get the best of both worlds. You get variation by randomization for each new run, because it will use a new seed in the next run, which might mean that the property runs 100 times fine, and in the 101st time it will fail. But from then on, it will fail with the same problem. Yeah.
Right. So if between runs in the CI, the workspace is either deleted or maybe the tests are run on different nodes in the CI, then we get this randomness again, right? Because we don't have any.
Yeah. So you need the seed, which is reported in the report. Yeah. Right. In that case, you need to choose the seed and inject it manually.
Right. So there was also a question about the about Kotlin native, actually, but I think it was expanding this question to a multi-platform in context of Kotlin. So currently, as I understand, it's a JVM library.
Yeah, I will get to that, to the constraints and what doesn't work.
So we get to that later. Other than that, there were like a lot of small comments and questions about what does this element do, or like if we don't specify unique elements, then all the elements in the list are equal. For instance, that was the question. It's a little hard for me to interpret that, but maybe you can.
I actually don't see the questions here. So if you don't make it unique, they won't be. Usually they will differ, but you explicitly excluding duplicates. And what the framework does is, if you don't say that it's unique, it will generate duplicates explicitly and on purpose. Yeah, because duplicates might mean a problem in your code, or they might reveal a problem in your code because you're not dealing with duplicates, stuff like that. But most of the elements will differ. Yeah.
Right. So yeah, I think we can proceed further for now. I'm still monitoring the questions, so folks, don't hesitate to ask more.
We will have time at the end, so I can stay till, well, not till 8, but I could stay an hour extra if you want to.
Yeah.
So this was the first demo, and actually this is what we did. We made a property out of an example-based test, and hopefully made it more generic and made it more documenting. Yeah, being more explicit about what are the constraints of what you have in your tests. So I think it should be. It's quite useful to think about what jqwik actually is, because jqwik is not an independent testing library, but it is a test engine for the JUnit 5 platform. And who hasn't thought about that yet is that who just thinks JUnit 5 is just the next step of JUnit 4. Actually, it is not. Actually, it's much more, because it's providing a lot of hooks for other test engines to hook into. Yeah, before JUnit 5, all the other test frameworks, like the old Spock or whatever you used, they somehow hacked into the JUnit 4 jar and tried to abuse it and try to abuse the IDEs to do what they want. And with JUnit 5, it's actually a service provider interface that is there. So that's why it's much easier now to come up with your own way of interpreting tests and writing tests and running tests. Yeah, because the platform does so much for you. And this is what test engine, and I think CodeTest is doing that as well. So who's using that? It's also a JUnit 5 engine, or at least it can be used as one. So you can use jqwik in Java, Kotlin, and Groovy. That's not to say that you cannot use it in other JVM languages, but that's the ones where I have tested it and used it in. There is an explicit Kotlin module, which does a lot. I will show some of these Kotlin-specific features later. Yes, it's generating data. You already saw that. It's doing it randomly, and it's doing typically. So there's what I called edge cases, and it's combining edge cases and all that stuff. And sometimes it's even generating the exhausted exhaustive set of all possible inputs. Yeah, for example, when you have like a parameter, a Boolean parameter, and an enum with 5 elements and a number range of 0 to 100, then it will generate like 100 times 5 times 2, like 1,000 elements or 1,000 combinations, which is all. So it's going beyond this just random generation. Equally important, I think, is to be conscious about what jqwik is not. And actually, it's not a fully randomized testing tools, because there are tools like that which will take your software and try to run all public methods with just random stuff, like setting all parameters to null or generating all over the place, all what you can think of. Yeah. This is not how property-based testing works, because property-based testing requires some deep thinking. It requires, I think, more thinking than you do with example-based testing, where you also have to think about what are good test cases, and so thinking about what are good properties is even more difficult, yeah, and requires more analysis, to be frank. And you should also be aware that even if jqwik does not or succeeds, yeah, everything is green. Even then, you have usually not proven that your property is correct, but it's the other way around. Property-based testing is like the scientific method for testing, because a property is a hypothesis, if you want, and the framework jqwik is trying to disprove it, yeah, to falsify it. And having a green property just means it has not yet found a falsifying sample. Yeah. So you should be aware of that. You should also be aware of that the learning curve for property-based testing is a bit steeper than it is for example-based testing. I have to admit that. I just have put a few of the things you have to dive into, or at least get a bit familiar with if you want to do property-based testing in breadth. Like how to generate domain-specific data. I just showed you just a little bit, but there is such a lot of things that you can do with the generators. There are a lot of primitive generators, and how you combine that, how you filter, how you map. There is a lot behind that. But that's just one side of the medal. The other side is the properties, because just generating data is important, but it's not trivial to come up with good properties. Yeah, so generic expressions that you can make, and so this is also something you have to learn. And but you do not have to start from scratch, but there's quite a bit of patterns and strategies for writing good properties. Actually, you find all that in this article, or you find links to that in this article I posted here down about property-based testing in Kotlin, and it gives you the necessary links to where to go from here.
Right. So I think regarding to that, we have a good question in the chat, like how to check that the app checks the contract. So if we set the correct contract, for instance, not more than 10 users, no spaces in emails, so our tests do not test the processing of incorrect input. So this is like a little bit philosophical one. How do you prove that your generators are actually covering?
Actually, it's an important point, because you have to develop trust into the generators. Yeah, and the one thing is that you, at a point for the standard generators that you use over and over again, you get a feeling for what is the range, what is the variation they create. But in the general case, and where you have a lot of combination, you might not be sure that it's covering all the potential faulty areas of the input space that you thought of when formulating the properties. And there's one tool that jqwik comes with, that is statistics. So you can generate statistics, and you can also make assertions about statistics. For example, you could check if you want to make sure that 10% of all the project names you generate are longer than 100 characters. Yeah, if you want to make sure, just put in the statistics for you check for the length, and then if you want to make sure that it's always doing that, you can have an assertion saying that make sure or fail if less than 10% of this criterion is fulfilled. Yeah, you can do things like that.
Right.
I hope that answers the question. And but that means for complicated generators, I have properties in my code to just check the generators, to get a feel for that, how the generators behave, and if they cover and how they cover certain areas of the input space.
Mm-hmm. Oh, to me, it just currently I wasn't thinking about it, but for me now this property-based testing is a sort of a tool for exploring the edge cases. Like I would ask you yourself, like this probably. Where do you see property-based testing in the testing pyramid?
Yeah. Actually, if you think of the layer of the levels where you can use it, at any level. Yeah, you can use it at the micro testing level, and you can go to the more integrated levels. What you have to be aware of is that on the micro testing level, running a test like 1,000 times or 100 times is not a big deal. But when you get to some external systems, like you have, it takes you 1 second to contact the database, for example, and 1 second is not a lot. Yeah, doing that 1,000 times means you have like 17 minutes already. Yeah. So what you have when you go up in the testing pyramid, you have to focus on tuning the number of tries that you use.
Mm-hmm. Mm-hmm. All right.
So we are already 50 minutes almost into the hour.
Yeah, we can probably start wrapping it up. The folks are pretty happy. I can see in the chat, and there were a lot of viewers, concurrent viewers today. So it seems that the topic is very interesting to the folks.
Yeah. I'd like to at least scratch a few of the Kotlin specific things, because I think they are quite nice, because this property-based testing and Kotlin fits quite nice. Yeah, it's not just a matter of a jqwik, but how the language does something. And for example, this type-based generation, because data classes are quite useful, I think. So in my Kotlin code, what I often do is, let's see, it's use type examples. Let's look at that. So, for example, what I have here is I have a class communication that has is using between two users, yes, and the user has some identity, which is a person and an email, and the person itself has an optional first name, and it has a last name which must be there. So. So one thing to tackle that, if you now need or want to have communication generated, you can use the hand-built, the tailor-made generators, or you can rely on type-driven generators. It's done with a use type annotation here, and if you look at the data classes, all you see is they get some user, and you have a few annotations here. Those annotations coming from jqwik. So you may not want to do that because it couples your production code to the testing library. But if you want to, you can. So let's see what's happening here. If it's following the constraints, like it's generating emails. And if we look at the generated things, we can see like the first name. You can see the email should be a valid email. Let's see if it has. Yes, it has the @ signs in there. We can see that there are the first name. Oh, it can be null, whereas the last name is never null. Yeah. So it's considering the nullability of this type. It's so it looks like it's following all this constraint. And but if you do not want to have those things in there, you can, for example, you can use like the contracts. You can say require and say last name length must be larger than 5, for example. And if we now rerun it, we'll see that hopefully all last names that are being generated have at least 5 chars. So at least at first glance, it looks like it works. So so you see, property-based testing, type-driven generation, and data classes work well together. This also works for type aliases, almost, except, and there is where one of the problems of jqwik comes in. jqwik is heavily dependent on Java reflection, yeah, and the Kotlin compiler has a few places where it's not really generating all the annotations that jqwik wants to see, yeah. And some of those problems is, I think, in this type aliases, but I'm not sure. But there are some of those areas where this is not working as one would wish to. But in the most cases, like when using data classes, it works as one would like to have. There is maybe one more thing that I'd like to show, like Kotlin functions, because Kotlin functions are such an improvement over the very heavy annotation with function and function to and by function stuff of Java. So if you want to like functions and you have code that is using functions internally, you can generate functions. Like if you're looking at that, it's this function takes 2 integers and should generate a string with alpha chars that is not blank. So, and also I have another feature that I haven't shown you yet. You can have assumptions here in your checks as well, like if you have conditions that span more than a single parameter. Let's see what it's doing. If this generated function, so it's the other way around. It's not testing functions, but it's generating function that should adhere to some certain specification. Let's see what it says. Function 2, expected value to be of type Kotlin number. Actually, it's class Kotlin string, which is true. Oh, I wanted to show you that it does detect something. So, because this function will always, because it's a function that's generating a string, it should run there. Let's check again and see if that works. And what we now see is that a function called with the same parameters will always generate the same values. But if you, for example, if you swap parameters, it should usually generate different values. It can sometimes generate the same ones. That's edge cases, yeah, because sometimes functions are constants, although they have parameters. But in the generic case, like here, if you swap parameters, it will produce a different value. So far about some of the nice things how jqwik and Kotlin combine. There's much more to that, but there are also a few problems, and the major reason for these problems is that the heavy reliance on Java reflection, yeah, and so that means that everything that Java reflection doesn't show. Like Java reflection doesn't really, at least as far as I know, doesn't show inline types. So the inline types just looks like the inline class. Huh? So that's why jqwik looks at that as the primitive class. Usually that's being inlined. Java reflection does not have the co and contravariant type restrictions, so I don't see them. Some annotations are missed still in the Kotlin compiler. and which I consider really bad or unlucky is that the Android runtime is not supported, and that's Android is Java, but the Android runtime does not support all of Java reflection. It does not support the annotated elements, so that's why this doesn't work either. So if you want to go, if you need like a multi-platform property-based framework, there is somewhere you can go. CodeTest has a property module, so you may want to use that one. There is already a rather recent article that compares, at least goes into comparing jqwik and kotest. So you might want to look at that to see how both of those frameworks compare. From my perspective, kotest is usable. I've tried a few things with it, but it's lacking quite a few features. Yeah, so that I consider important that the authors of kotest may not think are important or have not come to implementing, because kotest has a much broader space. So to the end, what are my lessons learned? So my lessons learned is that properties, I have used property-based testing for like 4 or 5 years now, and it is not a replacement for example-based testing. Yeah, examples are still a good starting point. I often start with examples because they are much more straightforward, or I have already examples from the domain. And sometimes I can translate those examples into properties, but sometimes they just stay. And just like Anton said, and then the properties are often an addition, because then you can explore the edge cases and things you might not hit by chance, or you might have forgotten to think about. We already mentioned that integration with the outside world can make properties slow, because a thousand times a short time span might make a longer time span. I've also learned that domain-specific generators make it much easier to formulate your properties. And I really like the combination of Kotlin and properties, because Kotlin has a few features that really make formulating generators and formulating properties very concise. So yes, contributors are always welcome in any open source project, I guess. You can find the code, and you can find the article I mentioned earlier. I'm open for questions.
Right. You actually answered one of the questions in regards to comparison of jqwik and kotest. Like there was one in the beginning, so there is an article everybody can read and make their choices. As I understood, the core difference is that jqwik relies on Java reflection and kotest probably not.
No. Kotlin is really multi-platform. CodeTest is really multi-platform. Right. Given some constraints, for example, when I read that correctly, is that CodeTest can't derive generators from types when you're working in the JavaScript, yeah, because then the types are not present at runtime and stuff like that.
Yeah, there is a question. I don't know if it actually is possible to answer. Is it possible to create a type generator for union types? But I'm wondering what kind of union types do you have in mind? Because there are no union types in Java and in Kotlin as well. So I'm not sure.
Well, I'd say my generic answer is you can create a generator for everything that you can do in Java or Kotlin. Sometimes it's not as easy to have a generator. If you think, for example, a generator for generating working program code, it's a really hard problem, yeah. And the framework doesn't solve that. But most of the time, it's more straightforward than you think.
Okay. My colleague Sebastian tells me that actually sealed classes are kind of union types, which, yeah, They kind of are.
Yeah,
Okay.
yeah. You can think of them as some types. That's, I think, what union types are the same, right? Some types and union types. Actually, the type-based generator will use that. So it will, if you have a sealed type and it has 3 subtypes, it will by itself choose between the 3 subtypes, the 3 allowed subtypes. Yeah.
Okay. All right. Then it was a great session. We actually were planning for like 45 minutes, but we were running for an hour, and I guess we actually have a lot more if we dig deeper a little bit about the generators and how we implement them. But it will probably take another hour for us to actually explore. And thanks, Johannes, for this session. And I hope folks liked it and they actually learned something new today. And it will motivate them to actually try it out in their projects. I'm pretty sure for the main specific things, it will be a very useful tool. So,
many thanks for having me, Anton.
My pleasure. All right, then the session is recorded. It will be up on our YouTube channel. So if you haven't subscribed yet, you should subscribe and hit that bell somewhere below the recording, and to get the notifications about the new videos being published on this channel. And yeah, so good luck everybody, and have a nice Kotlin.